I'll introduce you to Jonathan Mirtschin, who has kindly flown across from South Africa to be here with us. So thank you very much, much appreciated. I'll let John introduce and talk the topic for you.
Thanks Ali, and thanks to all the BIM Day Out committee for arranging such a great event. Just excuse me, I hope my voice lasts the hour. I have popped some pills, but they are only vocal zone for my gig, but I'll do my best, and if you can't hear, feel free to come to the front and where it might be a bit louder. Just to introduce myself quickly, so I'm not South African, but I am living there, my wife's from there. But I grew up near Melbourne and studied engineering and computer science as a double degree. Sorry, excuse me. I worked at Conor Wagner, now Archicad, for about 5 years, and then Expedition Engineering, which is an offshoot of Arab, for about 5 years. Project experience, Eureka Tower, which interestingly was a flagship or quite a prominent early Archicad project. But as an engineer working on it for 2 years, I didn't really realise that. All we were getting was DWG, as if it had come from AutoCAD. Lots of sports stadiums, so the Wembley Roof and Arch was detailed in Sydney, and the 2012 Velodrome, amongst some other bridges and stadia and other projects. The talk today is called OpenBIM, the shape of things to come. And I'm not sure how many of you guys have used IFC and how successfully and how frustrated or your own personal experience with the standard. I've been working with the standard for the last 4 years. So when I left Expedition, I formed my own small software development company, mainly to write tools for model exchange between one software and another. Because it's really, I don't think we're going to be in a position where any single piece of software is going to do everything perfectly for us. So, excuse me, on that basis, if no software can do everything for us, then we really need to be able to share model across multiple software applications and tools and processes. And that's where a neutral format like IFC, so Industry Foundation Class, comes in. Now, I could go into all technical details about what IFC can do and the new improvements in the ISO release standard, IFC4. But to me, the best way to demonstrate IFC, or to explain IFC and how it might relate to the projects and workflows that you guys do is probably to demonstrate it. Okay, I'm going to actually demonstrate this. Part of the work I've been doing as a software developer is turning a CAD application into BIM software, and this is a fairly unique CAD application in that it has a graphical programming interface. Some of you guys might know Dynamo or generative components, which has been around for quite a while. This is something similar, and you might see it's become very popular in a number of with young designers and in a number of universities, particularly for architectural and engineering colleges. Rhino, it actually started as an Autodesk plugin, and it's famous for its NURBs. So NURB is just a non-uniform rational B-spline, and what that means is it's basically a spline which is winding its way through various set-out points. So I can actually grab these control points and then and basically manipulate that curve. You can do the same with surfaces. So it's quite popular with push-pull type architecture, certainly very popular in offices like Zaha Hadid or Frank Gehry and some of those types of sculpted projects. The trouble with Rhino, like most CAD software and not really adhering to a BIM type process, is that really objects don't know their history or their purpose. Okay, so I can draw a curve, and the curve actually doesn't know whether it's a grid line or whether it's an edge of a slab or what it might be, but also it actually doesn't know how it was formed. So if I actually use specific points in this model, but then this isn't the control point that I was using before, but say a set out point, then the Rhino curve doesn't know that it really should redraw itself and adapt to those changed inputs. So within this environment then, similar to the generative components or Dynamo approach, there's this platform called Grasshopper, which is a plugin developed by the same developers as the Rhino 3D software. And really what this is a history capturing application where instead of just using the menus and the buttons and mouse to define step by step and then a change comes in and we go back find the last modelling step not affected by that change and redoing tasks time and time again. Instead, what we're going to do is capture the modelling process to define that type of thing. So I'm quickly going to do the same thing that I did in Rhino. I'm just going to associate with this Grasshopper definition these input points in Rhino. So then when I move these points, this curve will update. And then, so there's two types of components in Grasshopper. There's input generating or input defining components. And then there's components which will actually perform a function or a method based on the inputs that they're given. So I can take an interpolate curve function here, and I can wire the points into the vertices. Okay, and then we'll see on a virtual display this curve in green on the screen, and you will see now when I actually shift these points around that the curve will update and associate with it. Okay, you might have seen there are a couple of other inputs on that component. So I could actually take a Boolean toggle, say a true false value, and then this periodic input basically means is the curve closed or not. Okay, so here, if I toggle it to true, the curve will be closed. If I toggle it to false, the curve will open again. Okay, now you can expand this definition, and we're going to jump in the deep end in a second and show some IFC examples to generate actual BIM data. But just expand on this quickly for a little bit. Okay, I could further post-process this and say generate some equidistant points along the curve. So under the curve menu division, there is a component here to say divide curve. So I can wire that in by default. There's 10 inputs on that curve. There's all sorts of other controls, including like some stereo control knobs. There's numeric sliders. So I could actually change this to be integers, change the range to be, say, 0 to 30, or whichever value I get. Okay, and I can wire that into the number of points on that division curve. And so you can see as I move that numeric slider from left to right, the number of points adapting on that curve. Okay, you can take it steps further. Maybe this is a slab edge and we want to generate some columns on this thing, although I think I'm quickly going to scale the size of these points because it's a bit small to represent a real slab. But you'll note that the curve updates as I change the scale of the location of those points. And I can, for example, then set the length of this line to be something like maybe 2 meters or something like that. So I can type 2000 in, because this model's in millimeters, and then what we'll get is some straight lines extending from that. And again, fully parametric, so you start shifting these things around and the object updates. Okay, any questions on that so far? Okay, so what's this got to do with BIM? Okay, or IFC. Okay, so you might spend, and we'll look at some examples in a second, on developing a Grasshopper definition, but the last thing you really want to do is then take that to Archicad or Revit or Bentley or Tekla or Geritech, like Katia or whatever software you want to use for your BIM processes, trace it, and then have to manually recreate it. Okay, you've lost a lot of the advantage of actually preparing a parametric or generative model. Okay, so let's maybe have a quick look then. How do we actually add BIM data to this? And as part of this, we're going to look at what the actual IFC standard or IFC data structure is actually capable of. Okay, so I'm going to use this curve outline to represent what I want to have as the perimeter of my slab. And you should notice very similar steps to actually how you would define this in Archicad or Revit or whichever other software you might use to document this slab. So the first thing we might want to define basically is a material build-up. So it's a concrete slab and it's got this depth. So IFC, it really is just an open neutral database, similar to the databases internally used in Revit and Archicad and all the other software used in the BIM process. Of course, every BIM software has slightly different traits and means and methods of doing things. So IFC isn't going to encompass all of them, but you should notice a lot of familiarity. It should be very similar to what you would do in Revit, and the way that it can communicate and generate the objects in Revit should reflect that. Okay, so I'm going to define a material, and I'm going to define a material layer, which takes an IFC material, and I can give it a thickness. So if this is a 200 thick slab, okay, I'm going to say and I can wire that in then to the thickness input of creating this IFC material layer. Okay, if I want to create a slab, there's a couple of components we use for that. For Revit, we would define a family or a type of a family. Forgive me if I'm a bit Revit-centric. This is OpenBIM, but I'll stick with one set of common terms probably just to make things a little bit easier. But and here in this process, you'll see in a second when we import this into Revit, is that I can use a consistent name with the family that I have in the Revit already loaded in the project. It might have tags, shared parameters and things set up. So we could use a consistent naming system, and then it will either create the family if it can't find it, or use it if it can find it in the Revit project that's actively loaded when we import. The last thing, or the last couple of components we need, is something to say here is a slab object. Okay, so I can call up a slab standard case. This is the type. Okay, and then it needs a couple of other inputs. It needs to know basically where the perimeter curve is for the bounding curve or the perimeter curve of the slab. And then there's two other essential components for an IFC project, just to give an entry point into the file. One is basically to define the project and a root building or a root site. You'll notice that you can actually generate spaces, so architectural spaces. You can generate grids. We can generate building stories. As I said, it really is a comprehensive, open database framework to build up a BIM model. Okay, so I'm going to wire the curve in for the planar slab perimeter curve. In this case, by default, it's actually putting the slab at the bottom, but you can actually offset it down, similar that you can offset walls and things like that. I'll just ignore that just for the time being, but accept that I'm going to change that component, so by default, the perimeter curve would be at the top of the slab extrusion. Okay, so basically here with about 10 components, we've created the essentials of what an IFC file is, and we can now communicate that directly to Revit, or import that to Revit. So I've got a component here. These things are virtual, and the only things I can actually select in the Rhino document are the original points that are here. But what I'm going to do is there's a process in Grasshopper called baking, which would enable you to actually create native CAD objects again in the Rhino object, but they're static and they lose their parametric association. So there's a baking component here to say bake to IFC file. I can double click in here, and then I can create an IFC file just with this slab involved in it. If you've looked at your BIM software of choice, you would have seen all of the major parties actually have implemented IFC to at least some degree. Okay, so here in Revit, there is a native open IFC menu here, and if you've tried it, the biggest thing probably IFC has suffered from a chicken and egg scenario, so that primarily it's been used for coordination. The IFC framework's about, if it's capable of this, for coordination you really just need an extruded object or a meshed faceted BREP object, and then you can do overlays, you can do clash detection. You don't need smart geometry or smart objects really to do coordination. So unfortunately then there's this chicken and egg scenario where if no one's exporting high quality IFC files, no one has to import them. And if no one's importing IFC files, no one has to export high quality files. So what I've really been working on for the last 3 years really with IFC, and the last year particularly with Revit, is then creating an add-on on my own IFC importer for Revit to import these IFC, including IFC4, which is the new standard, ISO standard released in March this year. Also, you might notice that Graphisoft and Tekla have both also written IFC enhancing utilities to sort of enhance the native IFC import of Autodesk. So here I can then just choose that IFC file that I just created. Okay, and I guess because a lot of coordination, fairly primitive geometry objects have been used in IFC to date, also then the quality of the Revit model that you get using that is not particularly strong. So you get a lot of generic model in place masses. You want to go edit your model downstream, and then you're stuck with basically deleting that object and creating a true native one. So what I've really been trying to concentrate on working on with these tool development is generating native Revit objects, so that if a user goes to open that Revit model tomorrow, they don't know if it was imported from my plugin or whether it was actually generated by another Revit user. But you'll see here, so we do have a native Revit object. We could change the family assignment to another family in the object, or we could edit the boundary of that slab object if we chose to do so. So it really is a native Revit object. Okay, any questions on that? I know I'm moving fast, but I know I've also got limited time. So.
Looks awesome so far.
Okay, great, thanks.
John, can you take IFC files from other platforms rather than Rhino? That's using your plugin?
Absolutely. The tools are still a little bit work in progress then, because one of the other things with IFC, and actually what IFC4 has sort of tightened up on, is more standard ways of defining things. But they can, I mean, some clients actually like working in CATIA, but then their clients demand that they deliver a Revit model. So they're actually using then the importer to create a higher quality Revit file, even though they're not actually using Revit. So it is possible, and you know, certainly I will work with users if there are some small issues or particular aspects. You know, there's also things like struggling with Revit to create inclined walls and things for facades, which again, I'm working on perhaps some adaptive component type solutions and things for that. But it's not possible. You know, to date, most of the bottlenecks and things that I've been doing have been more the Revit API and how to create something, rather than the IFC framework being able to define or exchange that particular object. Okay. Okay. So now the Velodrome was a pretty successful project. It nearly took out the Sterling Prize. It got the public vote for it, but not the actual official award. Now, this was actually designed in generative components by Hopkins as the architects, and us as the engineers. There's no point using a procedure like Grasshopper if it then takes you, the engineer, 2 days or a week or a month to build a model just to assess one option when the architect's proposing hundreds. And there was a real design philosophy here that they wanted to make the Velodrome just like a bicycle. So sleek, efficient, you know, minimal object that everything has a purpose. So, you know, there's all sorts of factors that influence the success of a Stadia project. Sight lines for the patrons, the facade wrap. Obviously, the bigger the arena, the more expense in this wooden facade. From a structural engineering perspective, we want enough dip in this saddle-shaped roof so that the cables can span that long geometry and support the weight of the roof above it, the weight of the steel, the volume enclosed for the services. And even with arena, it's nice if all patrons can see other patrons. So if the roof's dipping and then patrons are blocked from seeing others, it diminishes the experience a little bit. So unfortunately, Grasshopper was a little bit immature to actually use for that particular project. We did similar routines and enhancements in Rhino, but I've post-applied the Velodrome to this particular to Grasshopper. So we can start to see. You'll see in a second. We went from a simple Grasshopper definition to something that becomes a bit of a bird's nest. Okay, so you and again, there are means of tidying this up. I'm not particularly the neatest Grasshopper modeler, but okay, I'm just going to zoom on this so we can see what we got in the Rhino viewport. Okay, so here's really just a mock-up of the bowl steelwork and the roof steelwork, which was pretty much done in generative components to be set out. But the nice thing then, if we can try to consider options about how big and what shape the bowl should be, is that then you can actually go in and you can and change a whole bunch of slider inputs. You can actually interact with spreadsheets, text files. Some guys, there's lots of third-party developers, which is what these IFC tools that I'm showing here is the work that I've been doing. But you can actually connect it to Wii controllers, internet sources, all sorts of things. And there's some sort of physics solver engines and other plugins that you can get for this. But okay, we could change, say, the number of grids. So instead of 36 grids, we want to cut out a whole bunch of steel. So let's just have 8 rakers and have a massive long support between them. So you can see now there that Grasshopper definition, the number of rakers is diminished. There's a torus set out, a donut with the vertical intersection to give you the shadow perimeter. And again, we can start to vary any of those sorts of set out distances or the overall torus shape. So I might not adjust that too much, but I can make various changes to stretch the Velodrome in one direction or another, and change any of the outputs, cable spacings, all that type of thing. Okay, now this is an IFC4 file that I'm creating. and I can now import that into Revit. So I'm going to do similar to what I did before, in that I'm going to bake this to an IFC file. Okay, and then I'm going to come back to Revit and import it in here. Okay, so you can see here that actually what it's quite quickly doing now is creating the families, because I don't have anything loaded in the project. Like I was saying before, we don't necessarily want my families being used, but we could have used consistent naming profiles so that they were utilised. Okay, so now I can zoom in on 3D. Okay, and we do have, as I said, native Revit objects. We have physical members, we have cables, and again, you know, it is native Revit objects. So I think there's one structural beam loaded in this architectural template, and I can change that cable to be a universal beam or some other shape or profile as I might need. Okay, questions on that? Yeah.
So with all those members there, is there some cases where it just duplicates, even though they're the same type, but they just duplicate?
Do you mean like coincident in location, or?
Yeah, like for instance, some IFCs that we've tried importing, they're the same doors, but in Revit when you import it, they're just two separate families?
Doors and windows, yeah. But like I said again, you might experience, I'm not surprised to hear you would experience some issues like that, but primarily because it has just been used for coordination. You know, part of what a big push I'm trying to do today, and in the work I'm doing as well, is just let designers know that, you know, it could be a better situation than what we're facing at the moment. You know, the software vendors are only going to respond if their clients motivate them to implement these sorts of technologies, because we spend, as an industry, far too much time coordinating models within our own practice or firm, let alone across a design team. Too much time checking, you know, and coordinating and all that type of thing. So what we're trying to, I think we're only on the cusp of what BIM and tools and the process is going to be, and you know, this is trying to push this in a certain direction where we can minimise duplicated manual work, but use more time thinking, or not be scared to test that option because it would take us 2 weeks to try and model it. You know, instead we can spend more time assessing different options and using our brains to pick the best answer rather than just let a computer do it, or that type of thing. What similar related to what you've just said, at the moment I haven't actually done revisions and modifications to the Revit model yet. So I will put a shared or project parameter on these objects, so I can try and identify if you import a new thing, it only updated modified objects. But so at the moment, actually the process is to delete them and recreate them so that you wouldn't have duplicate objects in place. But that's something that I'm working on soon. I don't know how I'm doing for time, but still got a bit of time. Okay, so for architectural or fabrication purpose, you know, we certainly might like nice physical members as basically what that would be fabricated or cut to. But then also, coming from a structural engineering background, we need to do analysis checks and bits and pieces on this steelwork to make sure it's big enough or strong enough, or needs more effort put into it. I can see a red component here, so this might not quite work as successfully as I might like, but what you can also do in IFC is not just have physical representation, but you can also have analytical representation. So from a structural engineering perspective, you can have releases, loads, you can have load cases, restraints, all sorts of things also built into it. And if you're a structural engineer, or if you'll have experienced the requirement that for, say, analysing this cable net where these elements join, we basically need lots of short elements along the length of the cable. Or as an architect, you probably had engineers trying to tell you to do that, or model columns floor to floor and this type of thing for various reasons. But also embedded in this definition is trying to build a smart structural analysis model as well as this physical object layer. So I'm actually quickly just going to start a structural analysis software just to demonstrate this. But so as part of this routine, it's actually, in Revit, if there are, I don't know if they've got structural engineers in here, you have the analytical or the physical member and an analytical member, which you can deviate from that physical location. but you can only have an analytical element per member. Whereas with IFC, you can actually have multiple analytical elements per member. So we actually can, if I just quickly jump to it. Okay, this is the Arab general structural analysis software, but I have links to a number of different structural analysis software. So here I'm actually going to convert or open that Velodrome model in the GSA software. Okay, so it should create a new model. No? Sorry, 1 second, I'm just going to try that again. And it's not just about structural analysis, it's also, energy analysis, especially with a parametric generative design tool, which could be very useful at the early phases of a design. We want all sorts of discipline, feedback and things. So again, the more information we can load into our model at an early stage, the better and more informed the design decisions can be that we can draw if we can analyse and use these models for this type of purpose. Okay, so I'll try once more quickly. Okay, so here we can see it. We can see why this is broken a little bit. They've exceeded some of the document tolerance and stretching with so few rakers. But if I turn on the physical members and then turn on their break positions, again, yeah, it looks like I've stretched that cable. You can see on the trusses anyway. And here I've actually left that edge as one physical member, but you can see here that the back edge has been broken into lots of smaller elements. So again, as I said, if you're an architect and you want to produce lots of options and get lots of good feedback, it's still no good then if all the other consultants need to take days or weeks to try and prepare and assess even a couple of those options. So if we can get as much smarts and intelligence into a central model file as possible, then the better the type of result we can get. Okay, yeah, I mean, that lists just there's some other neutral formats, mainly to do with steel. IFC is really a forefront runner and really very capable of all sorts of aspects. Just to look at that quickly then as well, it's not just structure and architecture, there's a whole bunch of stuff to do with services. So you can actually generate distribution, ducts and pipings, you can generate terminals and equipment. And including all the connectivity. So you should be able to do pipe sizing and all that type of thing, linked with all sorts of other software for designing and analysing the types of projects that you can do. And what I've actually been most recently working on then is IFC for 4D and 5D BIM. So it's not just coordination, you can actually have resources, you can have work calendars, you can have schedules, you can have cost schedules and budgets, and actually measure all sorts of metrics on your design tools. So, and we've seen some pretty impressive examples of that with other software already through the course of these 2 days. So what this process is then perhaps about is giving them a quick authoring tool to take it to that other software to do also then some of this more enhanced analysis and design decision informing type software. So I do have a small example. Actually, I don't know where the slide's gone for it, but here. So 4D BIM, so there's actually one other software that I know of at the moment already implementing IFC4. Most of the software vendors are saying that it's going to take them at least a couple of years to implement it. So if I can find it. Okay, I'm going to open a pre-prepared, so what I was working on is a quick crude example, and bear with me, this tool is brand new, even the constructivity. We were sharing files and releases up to the last weekend in just getting this to work, but we can generate all the tasks. So what I was working on here was effectively a core construction for something like Eureka Tower, where we'll do a double-story jump of the core and then follow up with the slabs behind it. And you can put in restraints. So, for example, for a structural engineering perspective, we said the core can only freestand 25 stories above the other superstructure. So you can build that sort of constraint in so that you can actually get accurate predictions of the construction schedule or time scale. So I'm just going to open this. The viewing's a little bit restricted, but we can then open that Gantt chart here in the software. Okay, I'm just going to scale it a little bit. Sorry. Okay, so you can see the core wall basically in double level jumps appearing here, and then the slabs following up behind it. And again, I mean, there's some other very impressive software we've seen, as I said, that we could take this into quite usefully, having authored it, but we can also do a quick construction sequence here. So I can say I want to animate this. I'm just going to set it so that it animates over a period of days rather than hours, and then I can hit play. I can't quite zoom in as I'd quite like at the bottom, but you will see this start to appear in a second. So you will see the concrete walls starting to appear down the bottom there, and then the slabs will follow up behind it. So, you know, this is a very simple example, and given a little bit more time, I'll start to do something more with columns and beams and that type of thing. But, you know, really we can hand over intelligent information using this OpenBIM approach without having to create the model in one software, recreate it in the other, and then add all sorts of other enhanced attributes if you want. One of the things I've got in mind perhaps to do is to add maybe sequencing or costing controls to Revit as a plugin or some of the other software if there's a need to try and do this type of thing. Okay, so just to quickly look at IFC4, it does have also constructive solid geometry. As I said, one of the frustrations you might have had, make a Gothic arch and then you import it and you just get this faceted object with triangle and quad faces that you can't manipulate and edit. But really this object can remain parametric. You can basically change the width or change the Gothic arch profile shape and that type of thing and have the object update. So here was an example more of extending a little bit on the simple example we did with a single slab. So here I took a mathematical form as a Klein surface, intersected it with various floor planes, and then generated a slab object at each point in time. So you can use particularly this type of thing for geometric set out of a project. IFC4 has NURBS, so again for railings and things like that. I mean, again, you might have been frustrated by the size of IFC files. It's not uncommon to get maybe close to a gigabyte of data, and that's primarily because they're taking spheres and meshing them into primitive in things that bloat the file. So it's actually not uncommon for a few objects to be responsible for a large portion of an IFC file, but the improvement of things like NURBS, and there's also for more like field display improvements in the way that you can store a triangulated meshed representation of an object. Here was an example from a student project generating a shading device in Rhino and then being able to take that into Revit and document it there. And I've also, I mean, I'm not the only one also doing links between Grasshopper and Revit. There's a number of other plugins, although they're primarily concentrated on aspects such as adaptive components or particular aspects. The beauty of me using IFC is I don't have to reinvent the bridge between them, and then it's just a matter of converting from one data structure into a Revit data structure or Tekla data structure or wherever it might be. Cardinal points as well. So one of the things, if you've ever tried to take an structural analytical model into Revit, is that the Revit user, whoever, will hate it because everything's on center lines rather than being set out on a top mid insertion or that type of thing. So again, IFC4 has many improvements in that area where we can use more advanced and sophisticated set out and then get that in the equivalent in the objects that then do get generated in Revit. I don't know how you fabricate some of these, but NURBS beams and things like that then are also possible to get that type of object in. Walls, and as I mentioned, services, wall grids, building stories. You know, it really is quite a capable, sophisticated BIM database. Again, how am I doing for time? Just about a little bit.
10 minutes.
Okay. Here's I have a few user examples. It's difficult to show, many of them, the tool's still emerging quite a bit, so you know, hopefully in the next couple of years more and more projects get constructed and can start to reveal about actually how they were designed or documented. Here we have a sports stadium in the Middle East, Thornton Tomasetti, American client, and they were using SAPS as the structural analysis software from CSI to do the member designs and bits and pieces, so the structural analysis checks and within that environment. I can't really say what this project is, but you can see here a fairly sophisticated steel set out in Revit. And here, again, it was a similar workflow where they were using Grasshopper to set out. So this is sort of a small slice of this project. it does extend beyond this and vary in shape and form. And you can imagine setting out all more individual members is quite time consuming, using more traditional modelling techniques. But here they were actually also then going from Grasshopper directly into this SAP 2000 structural analysis software, and then being able to change the sizes of elements in that structural analysis software. So of course, as engineers, the first size we pick isn't necessarily the size of the element we need, but they could do those design assignments within their structural analysis software, and then using similar to that IFC converter I used before into the GSA structural analysis software, they were using an exporter of mine to IFC, and then an IFC into Revit. And actually SAP does have insertion points and things, which is quite nice. So you do end up with quite a useful, sophisticated Revit model that's fully coordinated with any of the design assignments without manually going through and having to make changes and mark up drawings and manually model all this type of aspect. IFC also is capable of level of precision all the way through to fabrication. Okay, and I apologise, these examples are a bit structural, but as I said, hopefully soon I can get some slightly more architectural, because particularly in the States, there's been quite a nice adoption of the tools with some quite well-known firms there. But here, this is a canopy over a train station in Paris decode. We're helping with the Tekla design. So now with digital fabrication, where we can CNC or digitally fabricate steel without necessarily manually having to do that, there's less of a cost penalty for not having rationalised your structure. So there's not quite the same requirement to get everything the same shape and the same length. But of course you don't really get the full benefits of that if you still have to go digitally manually create it. Okay, so if some guy has to sit there for days or weeks or however long it might take and set out each one of those individual pieces, then you're just transferring from a manual process to a digital process, but still suffering some of the same effects. So these guys decode actually use Grasshopper. So you can see there's some slight variations in certainly in the spacing or the width, but also I believe in the connection between the various large steel support members. So they were actually setting out all the fabrication level of precision in Grasshopper, and then sending directly to Tekla, which can then digitally fabricate or cut the steel. But also I do have, because not everyone has Tekla. And more the fabricators and there's the subcontractors. But so also I have architectural clients which are doing the same thing. So they're setting out to a fabrication level in IFC and then sending that to the subcontractor, and then they're basically bulk importing into Tekla and then able to not have to manually model and coordinate or trace over that type of object. This is a similar story. This is a facade in the Middle East. And I mean, I don't think I can really say what the project is, but there is no two pieces of steel the same on this project. And again, then to be able to, you can set out all the bolts and the welds and the drill holes, and you're not suffering that same penalty for every member joining at a slightly different angle or having a different length or a different shape for that type of purpose. And it's not just, as I said, about structure. I think we're just getting sharper and sharper tools, and we're going to have more and more benefits as a designer or assets that we can collect and assess and use to inform the design. So I know there was a session on Vasari. This has got a virtual wind tunnel where you can actually pick a wind direction and a wind speed and then watch how the wind channels through an urban context or a project. And you can see, without physically model building, whether you need shielding in a particular area or this type of thing. I mean, there's also sorts of other aspects about the accuracy, and probably it's better for comparing two options rather than saying exactly, you're going to be fine sitting there, it's only going to reach a wind speed of whatever. But certainly also then, to be able to digitally explore, we should be able to come up with a better result if we take it to a wind tunnel test, or worse, have the project built and then sort of decide or discover some of these sorts of characteristics or aspects of our design that we didn't quite foresee. As I said, in Grasshopper also, if you're interested in that side of things, there's all sorts of form finding. You can run some of these structural analysis solvers in the background, or there's some plugins like Kangaroo, which are totally built into as a physics engine into Grasshopper, and do lightweight structures and long span type form finding to come up with the right shape. So yeah, that's the Gecko, or the Gecko plugin also links with Ecotech, so that you can do some of the more advanced analysis that's available in Ecotech. So yeah, I guess to sum up, I think there's a lot of frustration and suspicion at IFC as a file format, and fair enough. I mean, there's no single one person or body or reason why IFC hasn't worked as successfully as it should have to date. But as I said, the most important thing really to do if we decide that we don't want to build multiple models of the same thing and have to do all that, spend all that time coordinating and maintaining multiple models and things like that, is to really push and look for these solutions which bridge between all our different software and our different design team members and this type of thing. So yeah, hopefully that message is sort of demonstrated. I can't solve it all, but I can show that it can be better than what it has been, and then we can all put pressure, and it's only for the best for everyone involved in our industry to really push for the best design processes, tools and techniques that we can put forward. If you like some of this stuff, it is all on my blog. You can contact me. I can do online or physical presentations when the occasion arises. But yeah, please get in touch if you'd like to learn more about it or discuss it further.
Thanks, John. That's fantastic. I'm standing in for Ali in case you're surprised. Any more questions for John?
Is that compatible with Space Gas?
Absolutely. Actually, to be honest, Space Gas put me onto IFC. They've actually themselves, they're one of the few structural analysis software that have their own high quality native IFC importer. So yeah, I know the guys quite well. So certainly, I don't know if I listed that actually on those list of tools, but Space Gas is one of the engines that I'm working with as well. Sorry, it's not there. Oh, it is there. Sorry, you're right. Yeah.
How would that apply to architectural manufacturers' content? That's not adaptive so much.
Look, there's a lot of debate about if you don't get parametric objects in Revit. It's actually a side project we've been considering, and again, maybe I need to talk to the right people, or if you can put me in touch with the right people. But using a generative approach, I actually can generate different windows with different operable parts and different sizes and bits and pieces. So I think to date, lots of the manufacturers actually don't know Revit or Archicad or wherever you might want to get this content into. And so then they're investing a lot of manual effort and not the most efficiently way to try and do it. So it certainly is a side project where we've been looking at it for particularly doors and windows, but it could be any type of family that you might need. But then being able to maybe mass reduce it so it can be done more efficiently. And of course, we could use IFC as the basis, so then it can be used in Archicad or Bentley or wherever. But then we could also have advanced into importers like mine, or I could write another importer for another software, so that we still have like a native Revit family, even though it was derived from an IFC family. So does that answer your question? Or yeah. Okay, good.
We're actually users of Geometry Gem.
Great.
Engineering surveying company using laser scanning. Just wondering whether you might be able to expand a little bit more on, imperfect walls that aren't perfectly vertical, and how we can solve that problem in Revit.
Yeah. I wish I had the answer.
Does IFC allow for?
IFC, you can have any orientation of it. So, but like I said, what I'm thinking of doing is shipping with my Revit plugin an adaptive component family, which will take an extrusion width and 4 points, or maybe multiple points, so that you can actually generate something inclined. You can, of course, in Revit generate a wall by face, which is the easiest way to create something that's non-vertical. The trouble is, if you've got lots and lots of walls, is then you have to add lots and lots of mass objects to the Revit file, and I haven't actually got from the programming interface, the wall by face working for me yet. So there's a couple of things that I'm pursuing there. But the wall by face or the adaptive component are definitely the two techniques in Revit for trying to create a wall that's not vertical.
But your question more about non-uniform wall, like walls that...
Or you're talking about as built when it's not...
We survey existing buildings and we want to give them, and all that we can do at the moment is tag a wall to say that this isn't a vertical wall, even though...
we might be able, it depends on what precision is needed as well, because we might be able to fit a vertical plane through and accept that it's deviating a little bit from the actual physical wall. But otherwise, yeah, for wall by face or adaptive component wall. I don't know if you can make an adaptive family component, adaptive family a category of wall, because that's a bit restricted, but we could use something in lieu.
Another question back there?
Yeah.
Yeah.
So yeah, I know it's a lot to take in even in 45 minutes or an hour, but there's some business cards here, have a think about it. It lends itself to particular projects, and it certainly, Grasshopper lends itself to particular designers, but you know, it's not just about, I mean, as I said, I wanted to demonstrate IFC rather than just go through technical list of improvements, and hopefully you get an idea that it's a very comprehensive, capable database BIM format.
You may have already mentioned this, but the bit of the buzz around IFC4, how long in real terms would it be before it's inside some of the vendor tools?
And you know, we've spoken a little bit, because I do think a lot of the vendors do maybe use a core platform library for their IFC, so maybe if they get it, it might be faster, but most are saying a year or two.
But I think, John, the IFC2X3 isn't as bad as well.
No, exactly. No,
So
it's capable of an
viable
awful
as it
lot.
stands.
It is capable of all the 4D and 5D, but there are a lot of improvements in IFC4, which is one of the main reasons why I became an early adopter of it.
Well, thanks, John.